Alright, good morning. Now we continue with trigonometrical ratio as we started earlier. Okay, so initially we introduced ourselves to the trigonometrical ratios, which we learned that we are having tangent, the cosine, sine, and in short form we say tan, cos, and sine. We learned that when we talk of trigonometrical ratio, we deal with what? Right angle triangle. And with the right angle triangle, there are what? Two things involved. And they are the angle and what? Or the angles and what? And the distances. Like the distances of what? Of the lines that join to form what? The right angle triangle. So we initially learned that to find the angle, we must be given at least two of the distances. At least two of the distances. And when we are given the any two of the distances, we can find what? Everything. We can find every angles, and we can find every and we can find all the all the distances as well. So we proceed. We're gonna proceed and we solve some questions under that. So we have a right angle triangle like this. This is what? A right angle triangle, or something like this. Yeah, they say your right angle triangle, because we have what? This side to what? 90 degrees. Now it means that this side is less than 90 and this side is less than 90, because the total triangle sum up to what? 180 degrees. And if we are having only here to be 90 degrees, then the rest of the degrees will be shared between what? This and this. So 90 degrees, it is left with what? 90 degrees. Then here and here will sum up to what? This 90 degrees. Alright, so now we put that one aside. Assuming that we are given an angle theta over here. If we are given an angle theta here, we learn that the longest distance is always what? Hypotenuse, say h. This is always what? Hypotenuse, say h. Now this angle is facing here, so we say this is what? Opposite to the what? To the angle theta, and it is left with adjacent. So here we go what? Adjacent. Now assuming we are having the angle to be what? Theta over here, then here will be what? Will be called opposite. Here will be called opposite. Now we are having here to be always what? Hypotenuse, let's say h. Then it will left with what? Adjacent. Then we say here is what? Adjacent. Alright, adjacent. Here is adjacent. So you see, always we use the angles. We use the angles to what? To indicate where we can be called hypotenuse. No, the hypotenuse is always the longest one. Where we can call adjacent or the opposite. So we should what? Take note. Now what we are dealing with is how to find what? The distances. How to find what? The distances. So assuming we are given a question like let's say we have here to be 8. We have here to be what? To be 8. And we have here to be what? To be 4. Yeah, and let's say we have what? Some angle here. The angle is what? Is 60 degrees. Now, if we are having this question and we've been asked to find what the distance here, let me indicate here to be what? To be A, here to be B, and here to be C. So it means that I am moving from A to C. So I can pass here and pass here, I will reach the same destination. So from the law of what? Pythagoras theorem, you see what we are doing here, basically we are talking about Pythagoras theorem and trigonometrical ratio because they move together. With the trigonometrical ratio, that's when we talk about what? The sine, the cosine, when we want to use that what method to solve the distances and stuff. So if not, we use what? The Pythagoras theorem, which says that when I square the two shortest distances, when I sum them, it is equal to what? The longest one, which is the hypotenuse. So per this question, we want to use what? The Pythagoras theorem formula. So with the Pythagoras theorem, the formula says that this plus this. So I have what? Length AB squared, I mean this length, plus length BC squared plus length BC squared is equal to length AC squared, is equal to length AC what? Squared. Now, AB wasn't given, so that is what we are looking for. Means AB wasn't given. Initially, we said that when we are given two, we can find the other. So per this formula, AB wasn't given, so it means we are looking for AB. So we write AB squared plus BC. BC was given, so we have BC to be 4, but BC is squared according to the formula. So we write what? 4 squared. Now it is equal to AC squared, and AC was given. So AC was what? Given as, or perhaps I may say AC is given as what? 8. So we square 8. So we have 8 squared. Now we write AB squared because that's what we are coming to look for. Then we can send this one to here, but if not, let's do this one. This squared will give me 16, which is equal to 8 square. I think 8 square is 64 or what? So we have our calculator here. We can confirm 8 times 8, yeah, 64. So we have 64. Now this is a form of what? Linear equation. This is a form of what? Linear equation. So we want to find what? This. So we maintain this one here. AB what? Squared, which is equal to, we will send this one here, so it will subtract. So we just point 64 minus what? Minus 16, and it will give you 48, and it will give you what? 48. So we have let me write straight away 48. This 48 is what? Subtracting 16 from what? Because we are having 16 here. When it crosses the equal sign, it's gonna be what? Negative. It is positive here. Now we are looking for what? For AB, but we are having AB squared. So with this, we just take what? The square root of both sides. So we take the square root of what? Of this side. We take the square root of this side, so that this one will cancel what? This. Then we have what? AB, which is equal to root of what? Of 48. So we can point that on the calculator. So you have root of what? 48, which is 6.9. The word I'm having over here, it's a 6.9. So 6.9 is approximately 7 what? 7. So we have what? 7 units to the nearest whole number. So we have what 7 units. If we are not given any units like centimeters or something of that sort, we write what units. If it is centimeters, kilometers, or any stated unit, then we put it over there. If not, we write units. So this is what this is how we can get the distance when some of them is given, or when at least 2 is given, we can find the other. So per this formula we can do everything. This is what we call Pythagoras theorem. This formula is what we call Pythagoras theorem. All right, so we can also use trigonometry ratio. That's the sine, the cos, and the and the tan. Initially we talk about what we call so, ka, and toa. So we use so, which is the sine. When we have O and H, if we are having a right angle triangle like this is always H. Assuming we are having the angle over here, then here is O, and here is A. So